Now it is coming. Now it is coming.
Good evening, participant. Yeah, good evening, participant. Can you hear me? Just to give me the reaction. Participant, please give the reaction whether you are. Thank you, Vardhan Sethi, for your response. Prashant, good evening to you. Srinath, good evening. Good evening, Jagdisha sir. So the time starts right now. We can start our session. So Sujata.
Yes, Mukund.
Yes, Sujata, we can start the session.
Okay. Are you able to hear me?
Yes, Sujata.
Yeah, Sujata, I can hear you.
Yes, thank you, sir. Good evening to all of you. I'm Sujata, IT support member of NDRF, and today for today's session, I would like to be the host. Today is the second day of the 14 days of online internship program. And topic for today's session is drone technology, applications, future perspectives, and anti-drone technologies. And we would like to introduce a speaker for today's session is Dr.K.Ramachandra. So, request all the participants to put their questions in the chat box of our YouTube channel. We will take the questions from there. So please keep on posting the questions. Now, I would like to introduce the speaker of the session on drone technology, applications, future perspectives, and anti-drone technologies. Before going to the session, I would like to speak a few words about Dr. K.Ramachandra. We would like to look about his profile. A few lines about Dr. K.Ramachandra. Dr. K.Ramachandra was a former director of Gas Turbine Research Establishment, DRDO, Bangalore. He was a CEO of the National Program on Micro Air Vehicles, NDRF projects, and former director of NDRF. He is a mechanical engineer with a PhD and holds MBA degree in financial management. He has 30 years of R&D experience in gas turbine technology and has more than 15 years of teaching experience. He is certified with publication of more than 100 research papers and a textbook on experimental stress analysis. He has mentored more than 14 MTech and MS and 15 PhD scholars. He is a visiting professor in mechanical aerospace engineering in several engineering institutions, including RV College of Engineering, Bangalore. He is associated with training programs of several IITs and is a member of several professional bodies in the country. He is a member of Academic Senate, Governing Council, and Board of Studies of several universities, such as VTU, Dayanand Sagar University, Christ University, Shastra University. He is a chartered industrial consultant and is associated with Honeywell, Triveni Steam Turbines, Accenture, Caris Technologies, Wipro, Ashok Leyland, Defiance Technologies, Enlivening Technologies, and is now a technical advisor to both NDRF and Bharat Forge Limited. He is also the president of the Bird Strike Research Group of India. Well, a brief introduction of Dr. K.Ramachandra. Now I would like to welcome Sir for the technical session. And this virtual stage is over to you now, sir. Please welcome, sir, and welcome everyone. Please.
Shall I start?
Sorry for interruption, sir.
Yes.
Yes, sir. Yes, sir.
All right.
One more information.
Right.
So, participants, please put your questions in chat box in our YouTube channel. From there, we can get your questions, and Ramachandra sir will answer your questions. So, please keep posting the questions. Okay, sir. Proceed the session.
All right, great. Thank you, Sir Mukund, and of course, Sujata. It's my pleasure and a privilege to be a part of this internship program. And I welcome all the students who have registered for this internship program, and especially for today's talk on drone technologies and applications. Without much ado, I'll go to the next slide. Now, you must note that there's a background to these drones. The material that is presented is based on the experience with the National Program on Micro Air Vehicles, the DST, funded by DST, DRDO, and CSIR. We have the experience that we gained and achievements of all the consortium partners of NDRF who were part of this a big program. Then there was a big outcome of several NDRF seminars and workshops that has been absorbed into this talk. We had several interns who worked in NDRF based on the National Program on Micro Air Vehicles and associated technologies. And a substantial part of this presentation is drawn from open literature, from internet, and this is to acknowledge the source from which all this material has been drawn is from open source from the internet. So this is the background to this. And as far as the presentation today, 1 hour, maybe a little more, is concerned, I have got it into two parts. We will look at, therefore, as the title suggests, the drone technologies, applications, and future perspectives. The drones which are going on, which is a major breakthrough in our technology and UAV technology. And we also have a second part of the presentation, which is, of course, anti-drone technologies. Now, as far as the drone technology is concerned, very quickly we'll go through the status of drone technology, both in our country and across the world. And very briefly though, types of drones and their application potential, what are the civilian and defense applications. And I was a part of NDRF was a part of the Karnataka Knowledge Commission of the Karnataka state government. And we had a big discussion on the role of drones and how to go take it forward. So that we will have a quick look at that. We'll look at some quick potential and business potential. And as far as the students you are concerned, what are the possible job opportunities for startups and individuals? And there is, of course, there's a big need for drone pilots and pilot training, data processing, and cooperatives for carrying out this drone application. So we'll have a quick look at that if possible. And then, of course, we need to know people who are interested in drones, the DGC, the Directorate General of Civil Aviation, and their rules and regulation, which is the governing body for this thing. As we go along here and there, we will look at what are the possible projects that the students can take up for their projects wherever they are. And of course, the possible internship program later. And as I said, there is also a need for anti-drone technologists. It's become a disaster, really. What is supposed to be a very societally beneficial technology is possibly to turn around and be a big disaster for the system itself. And therefore, we need to have a need for these anti-drone technologies. How to handle these so-called rogue or unidentified drones, and which basically has about 3 phases of identification, tracking, and neutralizing them. And then what is the present scenario in the country? We will look at the challenges of anti-drone technology. And similarly, we'll also look at a possible set of projects and internship programs associated with this. Now, as I said, it's a very funny situation that we are in as far as the drone technology is concerned. It has not grown up too much. It's only about 20 years, 15 to 20 years old. Within that time, it has shown 2 phases of itself. It is very paradoxical. And it's wonderful societal benefits of many. It's a benevolent technology, very useful technology. And therefore, all the engineers and people who are developing these things are creating several versions of the drones. But at the same time, even before it has shown maturity, there are several misuse of drones. You have seen them, you have heard them. And therefore, this very same people who develop this, who are developing these projects or these technologies and vehicles, drones, they are trying to kill them, trying to neutralize them, trying to destroy them. So both creation and destruction are on the same, almost the same platform. We are trying to do both at the same time, which never happens in typically engineering history, but this is happening. Now, one request to internship program, interns who are attending this course. We are not interns, you are attending an internship program. You are participants from different disciplines and various parts of the country and various institutions. And you have this internship program is a series of open-ended seminars. It, of course, is multidisciplinary and interdisciplinary in nature. And we are trying to deal with advanced technologies and niche areas. I know it's very difficult to observe everything online in a very short period of time. And in addition, the webinar is not like a classroom. It's not based on syllabus or textbook. And there are presentations from different people in different styles, speeds, and accents. And therefore, I see your difficulty. But my request to you is please make an individual report of maybe 2 to 3 pages, 3 to 4 pages of what you've heard, technical issues and the concept that you have picked up as takeaway from each of these presentations, and submit it to NDRF within a day or 2 so that we can evaluate what is that you have heard, what you have taken away. And if there are some difficulties in understanding further, we can tie up with you. Quickly into drone technologies, there is a little clarity required. We call them by different names, UAVs, unmanned air vehicles, drones, MICAP. They're all the same, but they're unmanned. They're all operated remotely and programmed. Some of them are beyond visible range. and some of them are within the range. But UAV typically refers to the big vehicles, which are basically talking about defense applications, huge vehicles, and then the smaller, the medium size, the hexcopter, the quadcopter, etc., or the drones, which you are now referring to. And there are of course smaller, very small, shall we say, palm size or slightly bigger than that. And they are the MICAVs or nano air vehicles or micro air vehicles. So this is the typical definition of the system. And within the drone, I mean, within the unmanned aerial system, UAVs, or they are also sometimes called a UAS, unmanned aerial systems, we have different sizes and functionalities, and these different types of drones or the UAVs are designated as Tier 1, Tier 2, Tier 3, depending on the altitude at which they fly and the endurance, whether they fly for a few hours or a few days or a few minutes. This is all going to define whether it is a UAV of Tier 1 type or Tier 2 or Tier 3, and that's the sort of definition of a UAV. Basically slightly different from drones. Now, if you look at the drone technology, the growth of drone technology in a country and abroad, globally, you can see that we started long back, actually in 1970s, 80s for preparation times, and today we are in 2020. And if you look at beyond that, the growth in the country has been a little sluggish. We started late, we started slow, and we are not being able to press on quickly. And therefore, the difference in technological readiness in our country as compared to global levels is quite low, and we need to quickly bridge that gap. You can see this is the global, and this is the Indian scenario. So this, I think we need to, if you look at the spread of technologies, the market potential for these drones, I'm talking about it. There's talking about drones, it includes everything, both defense and civil applications. You can see we started early the small UAVs and MALE is medium altitude, low endurance UAVs, and high altitude, long endurance vehicles. And we also have what they call as pseudo satellites or HALP, high altitude, long endurance aerial platforms. We'll come to that a little. Now we are suddenly, anti-drone technology is also pitching in, and the business potential and the technology, the drone market is going to go up. And if we play our cards right, and if we push our technologies and work consistently with the focus, we are expected to increase our market potential in the country quite a bit. So this is something which you can do. And I was that we were a part of the Knowledge Commission of the state government of Karnataka, and the mandate was to look at what is the role of US technology, what is the status of US technology, what can we do to push that, and that was the mandate. And we looked at several technology which go into drones. If you look at, I have tried to divide that into 7 subsystems: airframe, structures, controls, algorithms, onboard electronics, propulsion and power systems, payloads, data processing, and UAS system operational experience. If you look at that, you were rather comfortable as far as the country is concerned with the airframe structures and materials, and not bad at all as far as the control algorithms are concerned, because we've got a strong software base, and our control system guys are also good. But what is really worrying us is the payloads, which is the camera and the telecommunication systems and so on. And of course, the most important thing is the propulsion and power systems. And this is very, very awful, because we have not done enough. So we need to be looking at this if you want to understand and improve the drone technology, drone operations in the country. And you can see, look at the left side, we have 2 restrictions, 2 low-end, two limitations, if you like. We don't have enough trained pilots. I'm talking about pilots who are trained to operate drones. And we also don't have much of a certification capacity for both the pilots and the drones. So this is something which will be very important if you have to increase the number of vehicles and application of these for both civilian and for defense applications. So this is something which I thought I'll mention this to you. Well, this is exactly what I've given in the previous slide. You can see aerodynamics of the flight vehicles, structures and materials, navigation, guidance, control, communication systems, which are in the drones, propulsion and power. This is the most important thing, and software and simulation. So there are several things. What is important is today's, it was a report in 2017. It has not improved much. It has improved a bit, but not much. Today, we are still talking about 20 to 30% of completely imported US and the drones. And what we are now operating are 80% to 70% are those which are built here locally in Indian conditions, Indian industry, which are bought out of imported components. We are not self-sufficient at all. And this is something which is very, very worrisome, and we need to do that. If you look at the footprint of drones in India, in our country, you can see the flappers, the ornithopters. Ornithopters are others called flappers. These technologies, this development which has taken place is based on our biological, the models, that is the insects. And the birds, which have actually inspired people to do a metallic bird, which is called ornithopter. This is something called a metallic bird. This was actually a disaster because the fatigue life, the endurance, the structural integrity of this is not good. These birds are actually natural. They have wonderful, wonderful strength, energy built all over the body, whereas here it is actually driven by systems, subsystems here, and they're not very successful. But this is the first initial sort of startups as far as ornithopters are concerned. But what we did recently in about 2015, 20, 25 years back, since 25 years back, we have developed a lot of small flappers. In fact, those flappers are actually emulating these birds, which actually can stay in one place by flapping their wings in a very peculiar pattern and keep staying. This is the hummingbird, the honeybirds, where we suck honey, hummingbirds. And this is possible to simulate. And this is the one which has been developed. There are several of these examples. A lot of work is going on in several academic institutions, but there's very little applications as far as the practical scenario is concerned. What is really useful and what's been used today is the development of actually fixed wing vehicles, small vehicles, maybe 300 mm, 400 mm, 500 mm sort of thing, and also fixed wings of this type, which of course can be assembled quickly on site. And this is something which happened. NDRF was associated with this national program, which was funded, as I told you, by DST, the Department of Science and Technology, DRDO, CSR. IITs and universities were our partners, and we did quite a good job of developing many of them. Some of the examples which our partners in the program are there are here. So the one which is shown here are the fixed wing vehicles done by some of our partners, as I mentioned, the consortium partners in academia. Those are the fixed wing vehicles, and these are the rotary wing vehicles, or the hexcopters and the quadcopters. Quadcopters with 4 propellers and hexcopters with 6 propellers. Several varieties, a number of them, as different configurations have been developed for several applications. Basically, it was a developmental program to develop a vehicle, control them, fly them, and control them, and do what is supposed to be done in a particular application field. So therefore, the question is, I want you to ponder about these things and get some answers. I'm not going to discuss this here because there's no time to all. How do drones develop both lift and thrust? Some of you are not into aero systems. Some of you are maybe from a different field, but you should know how drones, when they fly, develop both lift. They have to be aloft in the air and also move forward because thrust is produced at a particular speed. And how do they maneuver? How do you make the maneuver by a control system, which is handled by a control person who is controlling it far away? And we talked about quadcopters and hexcopters. So why not 3 propellers? Why not 6 propellers, 8 propellers, 12 propellers? And what is the basis for selecting these is the question. And therefore, what are the control parameters in a hexcopter or octocopter is a question that you should be able to answer after going through. We had a few interns working with NDRF based on several disciplines, but quite a few of them also worked in drones. And some of those things are listed here. You can see we had a tie-up with several academic institutions. They're all Bangalore-based. Some of them are from Hyderabad. Some of them are down south. And these are the examples of the vehicles that were developed with, say, for example, RV College, Acharya Institute of Technology, and of course the applied aeronautics and several, and there are private industries, private partners, private industry partners, DC Enterprises, Aerospace, who develop these vehicles. And we also ventured into giving a push to application of drones for medical applications, and this is listed here. But what is important is it is also mandated to develop a rotorcraft, that is the helicopter type of thing. What you see here is a drone which was developed early by Honeywell, but that is a different class of vehicle. And here is an helicopter, which is a mini helicopter. It's not more than a 300 mm in size. In terms of, and maybe 600 mm the propellers, but that's a mini one. What is most important thing is the drones which actually fly either as a fixed wing vehicle or a rotary wing vehicle, but they need to operate within small confined spaces, and therefore this transitioning or the hybrid fixed aircraft was developed, where you can see that this aircraft, this drone, actually takes off vertically from the ground, goes up. After reaching a certain height, it just tilts, becomes horizontal and dashes off. It's like a Sea Harrier aircraft, if you like, or a helicopter, if you like, but it's a fixed wing vehicle. So this technology was developed, and this is something which is very, very in, for example, agricultural fields where there's not much of a space for a fixed wing aircraft to be launched, or medical applications, medical supplies. So this is something. And this is something which we cherish. We love this particular concept, where this is a fixed wing aircraft which has got 4 propellers, which gives it a vertical lift. It goes up vertically, but there's also a vehicle at the back, which is a pusher type of thing. And this pushes the vehicle. And therefore, this one, though it's a very huge fixed wing aircraft or drone, it takes off vertically and then dashes off horizontally. And therefore, you can see it can lift off from confined space, climb, hover, and complete the mission task, land within a small space, because it becomes a helicopter to take off or to land. And this is something which was done by one of our students who worked in NDRF. He worked he was a student elsewhere. He worked with us as a partner, and he has developed this thing. So this is something which we were proud of. How do you handle this transition between vertical lift off and horizontal dash? After all, it goes up, and then once it reaches, it should tilt over in the case of a hybrid vehicle, and then it dashes up. How does the aerodynamics of the vehicle work without any complications, without any catastrophic failure of the system, is something which you must, as interns, understand and be able to ready answer some questions. So there are several applications for drones, and this I'm sure, as students of engineering, you heard and seen many, many such applications. I'm not going through this in detail, because then it's not possible to go into the details. And these are all familiar. These are all civilian applications. You can see the drones today, whether it's a rotary wing, say, for example, quadcopter or a hexcopter, or a fixed wing vehicle, can look at traffic in an urban scenario and try to help the authorities to manage traffic, give information on the traffic. It can give you the status of this situation awareness of a disastrous area. And then, of course, it can be used for monitoring mines, how the mining is getting progress. Is it going beyond legal limits? And then is there an erosion of the riverbeds or even seashore? Is something which these drones can do without manual effort, too much of manual effort. And you can see the importance of pipelines carrying gas and liquid fuel for a very, very long time, distances. And these drones, therefore, can be used to fly close to them and go at a speed which otherwise would be difficult for manual intervention, manual inspection. And this can inspect for maybe hotspots, leakages, and damages that is likely to happen. Or maybe if there's a landslide, for example, it may be very extensive damage to the pipeline, which is a terrible thing to happen. And this can be continuously be monitored by helicopters, the drones. And coming to agriculture, there's several activities in agriculture: spraying, pesticide spraying, sowing, inspection of thermal imagery, soil testing, crop damage assessment. All these things can be done very easily. RB is being done, and I'm sure it's not a news that I'm telling. You all of you know about it. But what is important is this is a hexcopter that was developed a long time back by our colleagues or partners, academic institutes. You can see what academic institutes and the students can do in developing a sprayer. This sprayer is not for crops, ground level crops, but trees, if you like, plantation, banana plantations, mango trees, or coconut trees, and so on. So this has been done. So this is also being extended very logically to medical applications. We can transport medical organs through drones from one hospital to another hospital within a short period of time. We don't have to go through the road. We can't reach the airport because of traffic jams and so on. Organs would be damaged, and therefore we have launched many programs of it is all over this country. Many of the education institutions, IITs, many biomedical engineering departments have started working on this. But what may challenge you is this. This is something, is a container in which the heart is transported. This is nothing to do with drone, but it's something to do with medical electronics, biomedical engineering. This heart, which is being transported, is kept in a small machine at a temperature of 4 degrees centigrade, but it is pressurized, kept pumping, so that it is active throughout, and it can last without any damage for more than 12 hours, which means what? You can transport a heart from Trivandrum to Delhi without serious problem. The organ will reach the patient in time without getting damaged. That's something which is happening in a big way. So you must see the potential of this. So can you really look at slightly away from drones, can you look at what is called perfusion containers to keep the heart active, warm, and healthy? And this is something which you must really look at. And drones, of course, Amazon, Uber, they're doing deliveries of cargo elsewhere, but we have a problem here. They're not been approved by DGCA, the Director General of Civil Aviation, to do this, but it'll come soon, very soon. And you can see this right-hand picture image, which I've just taken from internet. This looks like a mini transport aircraft, just as big as that. You can see things are being transported. And this is some area where you must put in some effort. And the firefighting, if there's a fire in the center of Hyderabad or in Bangalore or Delhi, for example, in a tall building, it's very difficult to reach in time. Firefighters won't go there. So even if they reach, they may not be able to reach the 32 floors, 20 floors, and so on. So here is what is the system, the drone system can do. It can carry, it can assist, it can support firefighting in major forest fires and urban areas. What it can do, it can reach the height very quickly and try to douse fire. It can take pictures of what's inside, what's happening. Are there patients, are there people who are very, very badly hurt and suffering? And all the data can also be brought down. This is happening elsewhere. This will be useful in the coastal areas, in big beaches. And what is more important is these drones can really help people to sort of rescue people who are getting drowned. Maybe a fishing boat, for example, if it is hurt, if it is damaged, the fishermen can be helped with these life jackets. And now we developed a lot of sensors in NDRF through this program. We developed biosensors, the sensors which are based on biological process. I won't go into the detail. And this is a sensor which was developed in collaboration with private agencies, nitric oxide, ammonia, and carbon monoxide at ppm level, ppb level. Parts per million levels, very, very minute quantities of this can be detected, which means you can detect explosives, you can detect drugs and other things. Now, there are a lot of exercises being done, is going on, and to put these sensors on drones and try to see if there is a dangerous area, say mining, mine-ridden fields, can we detect them? And things like that. So there are a lot of work, application work that needs to be done. And this, of course, is not a necessity to highlight. There are a lot of work is going on. This could be a few years away as far as we're concerned, but there is a taxi service which is already in Dubai. We are talking about recreational drones, but basically it's going to happen unmanned passenger transport aircraft, like the e-mobility cars and like automobiles. We are going to have passengers being transported by drones without a pilot. So this is something. As I said, we had a lot of interns working with us in drone technology and its applications. And this is something which is you must know. You must understand that drones are basically a ground, air, and ground. But can we modify them to become aquacopters, which means that they can take off from land, fly in air, land on water, and move up like a boat, can it move on the surface of water and take off from water and come back to land. This is the role of an aquacopter. And this was sort of this concept was converted into a program, into a hardware, into a drone by one of the interns in NDRF, and she was working for an engineering college. And this is what's possible. You can see this drone, which took off from somewhere and from the land. It's landed on water, is being tested in a small little testing pool. And this is something which is important, for example, in areas where aquaculture is going on. We can monitor the quality of water with the sensors which are fixed to the drone, and therefore it can do pollution control in air and water quality studies in water, and without having to train people to go in a boat and collect samples of water and so on. These are all automated collection of water quality data in aquaculture. And this is something very, very interesting. This is typically a Bond movie type of vehicle. This is a road vehicle, four-wheeler, but if it is required, it can take wings and fly in the air and land back. But what is the advantage? Why are we worried about? Why are you so interested in this? This again is an agricultural possibility or a forest area where there is no way of guiding these vehicles to take off and land. So it can do by itself. It can be programmed. And this can do surveys of wild animals, forest flora and fauna, and of course, agricultural applications. And there is a possibility that these drones which are flying can be used for environmental studies. Now you can see the drones actually are limited by today by the power, that is the battery power that it can carry. Batteries are very heavy these days, and they become lighter anyway, but they're still heavy for this to lift, because there won't be enough capacity for the payload, other payloads. And therefore, if you fly an X-copter or a quadcopter and connect it to through a cable, a tether, which can get connected to the battery on the ground, it can be at about 1 kilometer or half a kilometer, 2 kilometers in height, but it's connected to the ground and it is mobile. It can be mounted on a mobile vehicle, but this tethered vehicle can run continuously for maybe a day, not just 20 minutes. It can maybe run for two hours, maybe 1 day, maybe 3-4 days. So what is the advantage of this? It can be moved from one place to another. We can look at the agricultural crop status. We can monitor weather. We can monitor, for example, it can be one control center for traffic in Bangalore city, for example, where it's very, very crowded. Otherwise, it's very difficult. It's unmanned, and no man is required, it can collect data from the place and transmit it to the police headquarters or traffic control station. And similarly, it can also work with an aerostat. It's nothing but a static, there's no propulsion system there. It works on the principle of buoyancy, and both together will do a lot of work. So the question therefore is how to modify drones to work as amphibians and entomopter. This is one typical question. I thought I'll mention this. Now just give me a minute, I'll come back. Okay, so there we are. What are the future perspectives of future status of drones? We're talking about immediate future. Now, what you see in the left top here is a map by a satellite, maybe ISR satellite, any other satellite. It gives you an idea of what sort of sea conditions are existing on the sea coast. And this is also possible today to find out from the satellite pictures which area close to the sea coast, maybe within 30, 40, 50, 100 kilometers, which is rich in fish. And therefore the fisher folk can go to that place with their boats and make a quick catch of the way they want. Otherwise, they will be hunting around without knowing. They have to spend a lot of time and guess to get the type of fish and the quantity of fish they want. And this is possible today through a satellite picture. But then satellite picture is taken from a distance of maybe 100, 1,000, and depending on the orbit of the satellite, which is looking at this. And this is period. It is not continuously possible because the satellite comes around in a particular frequency in a cycle. But if you use a drone close to the sea, maybe from half a kilometer from the height, or maybe 2 kilometers from the surface of the sea, you can catch this picture and find out the quantity, the type of fish, etc. May not be the type, but that is the quantity, depending on this color. But to do this, the drones must be equipped with what are called LiDARs, multispectral and hyperspectral camera. And therefore, you are going to be in understanding, integrating these payloads onto the drones, flying over the sea and getting this picture and analyzing, and tell the fish folk, I mean the fishery department and the fishery persons to go to that spot and that particular time zone and then make a big haul of the fish. So this is something which is going to help in fish culture, I mean aquaculture. Now, we also have, we have a plan. We have done quite a bit of initial work, but then I'm sure somebody is going to take over. There's a migration of type of tortoises. These are called olive ridley tortoises. And there are millions of them in a particular season along, for example, in Orissa coast. And we are not able to see what is their living habitats? How do they come? How do they hibernate there? How do they bring in their small kids? How do they go back, hatch and go back into the sea? All these things cannot be done because we have to disturb them. We can't use mobile vehicles. So if you use drones without hurting them, without disturbing their ecological place, we can do a beautiful, very accurate survey. So the sea fauna survey is something which can easily be done and very reliably be done. It will be a wonderful, wonderful thing for an environmental group of people. Now, if drones can be fixed with what's called a gigamilli counter, I'm sure most you students would have learned in 12th standard, I mean, 10th, 12th standard and initial days of the college, what is atomic sensors for looking at the atomic radiation, the gigamilli counter. And if you can fix this gigamilli counter to drones, maybe a fixed wing vehicle or a rotorcraft, I mean, rotor vehicle, that is an X-copter or quadcopter, you can fly around the nuclear plants and the surrounding area and find out if there's a leakage of nuclear. This is a very serious health potential, I mean, health hazard, not potential, health hazard. So it is very difficult to actually make a survey manually And there are, it's done periodically as a routine basis, on a routine basis, dependent on what the regulatory commissions tell them. But the drone can fly around, not only in the air, but also in the water surrounding. The nuclear waste is pumped into the sea, and that is at a higher temperature, maybe 5 degrees or so, and it contains continuously some radiation level. So this can be done by the aquacopter, maybe small boats can be done. So this needs understanding of gigamolar counter being integrated on the drone and fly and make sure that the environment around nuclear power plants is good, safe enough for people to live without a fire, without a fear. Similar thing can also happen if you use drones, and there's a very difficult area, a difficult situation. The use of drones for looking at the bird aircraft strike management. You must prevent birds coming into the airport. The airport is typically about 4 or 5 kilometers in length and about 2 to 3 kilometers across. We need to sanitize the whole volume around the airport without from these birds. And this can be done by drones. I mean, if the drones can have radars and fly them, small radars, it's very expensive, it's very difficult to get such radars that are being developed. But we can also have lasers mounted, chemical sprays mounted, put on the drones. They can move around the airport and see and keep birds away from the surroundings. You can see I've shown a picture of a drone, an aerostat, which is a balloon, which is now just on a mobile platform close to the airport. And this will have video camera and all this system that I've been talking about to scare birds away from airports. So this is something which is a very important thing. And this is important not only for this, for agriculture. During the period of sowing, during the period of harvest, about 15% or 20% of the crop is taken away by birds, apart from other rodents and other things like rodents, but birds also take away. So if you have this system incorporated in agricultural fields where a large tracts are being cultivated, you will have a tremendous potential. So I'll skip this because I need to rush through. Now, today we are talking about one vehicle, one drone, but tomorrow it's going to be a swarm of drones. How to fly many of these together? Because one cannot do for example, if you're spraying a large agricultural land, you can't do that with just one drone. You may need 10 of them, maybe 5 of them. So how to make 5 of them fly and do their work, what is prescribed to them, without colliding with each other and without colliding with any of these obstacles in the field, maybe an electric pole, electric transmission tower, big hillocks, and things like that. So you need to have what is called swarm flying and obstacle avoidance. This is the classic case of a classic example of what you're going to study, the artificial intelligence and machine learning. They need to be miniaturized. They go into this system of drones so that they can do this work. Obstacle, first of all, you have to detect obstacle and then avoid obstacle. And while doing that, you don't want to deviate from your main mission objective. And at the same time, you don't want to clash with other swarm members of the swarm. So this is something which is a good example of drones absorbing artificial intelligence and machine learning, which is and data sciences and so many. All the new things which you're now talking about will go into this drone technology to make them more productive. And so, for example, if you're flying from Bangalore to Hyderabad or flying from Bangalore to Chennai, the drones have to fly to deliver a goods, a cargo, or maybe a medical organ, for example. While they're flying, they must look for electric poles, electric transmission towers, maybe windmills, maybe big hillocks, water bodies. It should fly perhaps into a fog or a rain. And most important thing is if there is a lightning. Today, when I fly a drone from Bangalore, I let it go, program it and let it go. But after 30 kilometers of flight or 50 kilometers of flight, I don't know what is the weather condition there midway. So if there's a lightning, we have a problem. The drones should be able to withstand the bad effects of lightning. Lightning also has a problem of EMI and EMC. So we need to make sure that the drones which are now flying should have EMI, EMC potential to avoid bad effects of this EMI and EMC. They must be resistant to that. And they must also look down and see they're not flying over very highly populated urban areas or rural areas or highways and train tracks. So there's a lot of artificial intelligence we should go on drones to make these drones meet their mission objectives without with the highest level of reliability. And today we're talking about not drones which are flying maybe 2 kilometers or 3 kilometers in altitude, maybe 5 kilometer altitude. We are talking about parking drones at altitudes of 25 kilometers in the stratosphere. They're called high altitude pseudo satellites, HFS, or otherwise they're also called, I'm sorry about the spelling, high altitude long endurance aerial platforms, HALEPs. So these are actually drones of a different kind. Drones which are probably based on power, electric power and propulsive power, but they're not somewhere here near the stratosphere where the temperatures are comfortable, the wind directions and the drag that you get out of this wind resistance are all minimal. And therefore, they are very, very useful to today's context. And they can stay there, get themselves parked for not 1 hour, 2 hours, but they can. We are now going through a program in the country for having HALEPs can stay in 4 or 5 different locations for more than 5 months or 4 months in one go. Once they are launched there and parked there, they're moving slowly, hovering, but they're going to stay in the same, almost same altitude, not exactly the same, but very similar altitude for 5 months, and look down and see what's happening to the wind, weather, maybe it's a homeland security issues. Is there any movement of ships and aircraft which is unexpected? And all these things can be done by these HALEPs or the pseudo satellites or the drones. And they can also look at, for the homeland security, crop seasons, floods and weather monitoring. So there are a lot of issues that are involved. And therefore, we need to look at them seriously as a futurist. And they're already there. They're already there abroad. We have actually at least 15 years behind, and it's high time that we put our vehicles into space. And what are they? They look like this. You can see a small propulsion system attached to a big balloon-like aerial platform. And you can see on top, power. This cannot have batteries because battery become very heavy to launch and keep them at 25 kilometers altitude for 4 months and 5 months on end. And therefore, they are solar powered. You must have solar panels. You must understand solar panels. They are flexible and they're very highly efficient. We're talking about not just 22% efficiency of solar panels, which is there on our rooftops, but we are talking about panels which are flexible and having efficiency, and it's a very high expectation, but 40%, 44% perhaps. And so they are all several solar-powered aerostats working as HALEPs. They are drones, in other words, but parked in stratosphere. So something which is important. There are application challenges. So a few disruptive technologies which will come. I said, it's not a challenge, but inadequacy. If you fly a drone for, say, 1 hour in an agricultural field or in a course, you collect data, but you have to process once. The processing of data is dependent on the processing of the image data that you get to find out the contours, to find out the crop pattern, to find out the weather conditions, and so on. If you run and collect data for 1 hour, take a bet. You need to have at least 5 to 10 hours of processing. And you need to have system to do this, software to do this, and you need to have at least 2 or 3 trained person to work around the clock. And this one hour data is not enough for a very huge application, for a very huge land. If you want to survey, for example, some desert area in Rajasthan, a forest area in Kerala, you might have to have 4 or 5 of them working continuously And therefore, the amount of data crunching, data processing, special data, special software become bigger. So there is a need for training of people on the software and processing data. This is the limitation. And today we're talking about drones of a special kind. If you look at fixed wing, they are a huge one. I mean, it could be 1.5 meters in wingspan. And this you can't carry in the forward area. The soldiers cannot carry. There's a possibility that if you have a proper material, you can roll them into a roll and put it in your canister, and it can be carried on your backpack. And therefore, when you go to the place where you want to pull it out, and bang, it goes, becomes a fixed wing vehicle, but it still has enough strength and stiffness to withstand the flight loads. And when he launches, it is going to fly like a good fixed wing vehicle. But what is the material? How do you process it? How do you manufacture which are a part of this foldable fixed wing technology, and we need to be doing it. And I don't think I need to mention, I'm sure most of you know what are fuel cells, and there are several kinds of them. We've been talking about fuel cells for decades, but we're not being able to do a big progress, big jump in in fuel cell technology. There are several of them. I don't think I need to talk about this here, but it's all being done across the border by our neighbor. It's all a monopoly of Chinese and other people, and therefore we need to push put in a lot of effort in developing miniature fuel cells, medium-sized fuel cells, large fuel cells, both for the aircraft, big aircraft, passenger aircraft, as well as for drones. And this is, without that, we will only be talking about the thrill of flying for a few minutes, for a few, perhaps hours, but not beyond that. So fuel cell technology is something which is a must, and you can see elsewhere, already there are gliders which are working, there are already high altitude air vehicles which are all working on fuel cells as well as solar panels. So these are the two additional technologies which would support the drone technology if they have to be fully exploited. Now we are talking about drones. We are talking about one drone, but you can see if you look at the airport like Bombay or airport like Bangalore, or maybe there are about 100 flights or 150 flights landing and takeoff, and that's handled by air traffic controller. And that is a fixed timing, and there is a connectivity between ATC and the aircraft continuously. So there is already a big sort of pressure on the ATC to handle 150. But if you allow drones to develop the way it is developing, you will have in Bangalore itself maybe 20,000 drones flying in a day, maybe 5,000 in the night. So they'll all be flying like birds, and there is absolutely no control on them. There's absolutely utter chaos. And therefore, we must have a system of controlling once they become very easily accessible, doable, and flying, doing legal things. And they'll all crash. They may collide with each other. And it's not only collide with each other, they'll fall into places which are going to be very, very badly affected. The collateral will be very high. And therefore, we need to have, we've been discussing with the DGCA, that is Directorate General of Civil Aviation, and the Ministry of Transportation, the Ministry of Civil Aviation. They are all looking at a possibility, this without which it's difficult to manage this traffic, the drone traffic. So they want us to develop what are called virtual traffic control, drone traffic control in parallel, or as an additional layer along with the existing air traffic control system in the airports. So see, now in Bangalore, there'll be 2 or 3 air traffic control systems. But if all the drones come in, there will be thousands of them. So we might have to have at least maybe 100 or 200 small little clusters where the virtual drone traffic control system should be done. So you guys should think of models, possibilities, and the way, for example, the existing towers, the transmission towers, not about electric towers, but the internet towers. And could they be used as a virtual platforms where they can be interconnected to give a good network of traffic control system for handling drones? So this is a challenge. The students should explore all possible means and mechanisms for developing a parallel layer of drone traffic control along with air traffic control systems. So this is going to happen. Today, it's just a picture. It's going to be a reality, and it's going to be worse than what I'm showing. Therefore, you want to exploit the drones. You don't want bad incidents, you want easy life. You need to have a control system like the ATC for the aircraft. For drones, you need to have a committee. And that means that you should have technology for looking at dynamic swarm control, recognizing them, making sure that they talk to each other, they talk to their control system, and all of this thing that's happening in ATC, you should. So this is something which I thought I'll let you know, but since the time is running short, I'll skip this, quickly go to the next topic, which is anti-drone. As I was mentioning, drones, they are useful to society. You are building them. Drones which are going to be harmful to the society, you're going to kill them. You need to see how to do it smartly, how to do it effectively without hurting anybody, hurting yourself. There is an urgent need for anti-drone technologies and systems. This is just obvious from what you have heard, what you've seen. We can see a cluster of pictures where there is a security threat because of accidents. There are many accidents, like you're seeing in the middle column, and there's a nuisance and privacy issues are involved. And all these things call for controlling, avoiding drones when they're not required. And that's one issue. Second issue is you're flying your drone in your border, and somebody from the other side of the border takes it away by taking care of, like a hoodoo. They mesmerize, they hypnotize the drone by spoofing and takes that away. Maybe 1 or 2 or 10 drones, all of yours being some job is taken away by hacking, drone hacking, which is done by spoofing. What it means is you send to the control system of your drone fake geographical coordinates and then deceive the onboard system and then hijack the vehicle to a different place, which is not your intention. And it is taken away by the person who is hacking it. And this is something which is easily done today because most of the systems are unencrypted. They're not secure. So you need to safeguard, avoid the spoofing. Well, as you're going to use spoofing for anti-drone technology, you don't want to get spoofed up, goofed up, if you like. So drone hacking is something which you must avoid. And if you look at drones in civil aerospace, like I was talking about, there are several issues of safety, security, air traffic management, regulation, and socioeconomic. We can see the insurance also is a possibility. Some of you guys who understand drones should interface with legal issues, insurance issues, and this is something which will be much, much useful. I won't go into the details. And this the unauthorized drones come in because of external threats, maybe across the border, and then internal threats because of the infiltration and all sorts of things which are happening within. And therefore, there are a lot of regulatory bodies which we need to identify who is responsible for doing this anti-drone technology. It is not good enough if you develop a technology. You can't use that technology yourself. It should be authorized. Somebody to shoot down a drone, everybody can be shooting down drones everywhere. It has to be regulated. It has to be identified. And for each type of vehicle, each type of scenario, there must be identified regulatory and responsible identified persons or agencies to be developed. So there are several ways of actually identifying drones which are unauthorized, drones which are rogue, drones with a malfunction and bad things in an idea. You should be able to identify whether it's a friend or foe. This is something very important. The basic thing is identification of a drone, first of all, located, because they're so small at 10 kilometers, 5 kilometers away from your point of inspection that you may miss them all. You need powerful radars, but to detect such small drones, which are very good, low radar signatures, very difficult, but still you need to have develop better them every time, each time, and have radars, radio wave receivers, audio sensors, optical sensors to detect them, to identify them, and then to defend yourself, to defend your assets. You got to have jammers, spoofers, like I was telling earlier, hackers, and destroyers. We'll come to that a little later. So these are two levels of technology. What go wrong? Everything can go wrong. Industrial side, private property, there are extreme cases of station, and so on, offices, and of course, big events, maybe IPL, cricket match, or Euro Cup. All these things can be at risk by drones. And just to give a glimpse of what can go wrong, what can be hit, you can see the beautiful pictures of our administrative systems, hospitals. Water cleaning bodies can be very easy sort of targets for very large-scale destruction. Nuclear power plants, airports, oil wells, everything. And all the software companies, for example, they're all prone to hit. All places of worship and places of large congregations. You know, you can see the Kumbh Mela and all sorts of things happening. And if one drone can do a bad thing there, you are hit. You remember this, this happened in, I'm sure most of you know, it happened about 15 years back and in Jammu, in Jammu and Kashmir. So this happens to an Air Force station. And you can see what happened with a drone like this in Azerbaijan. It is actually a war scenario, war theater. And this is done by a simple quadcopter or a hexcopter, which can be built by buying small little gadgets in a typical hobby shop, and that's what it can do. So this is the potential, both negative and positive, of drones. It can do what it did to oil wells. The whole thing of 10 to 15% of oil revenue was lost. Very well guarded. White House was there. I mean, people saw a drone around that, and so many things can happen. The Heathrow Airport and the adjoining airport, Gatwick was shut down because one drone was seen in the airport area, and lot of 4 days, 5 days, 1 week of cumulatively the airport was shut down, and it took about 15 days for the entire set of people to get regulated through flights. And you can see what it can do to VIP system. This person was killed in Iran, and Ecuador president was almost killed. And this is what it can do, and therefore you need to look at it. And this was all done by single drone. Right? Yes, this is what is going to happen. It's need to handle this. Therefore, the drone market is going to be big. Already we have many private players, industries in India developing anti-drone technologies.
Sir, can you please unmute yourself, sir? Ramachandra, sir.
Right.
Yeah.
Yes. Okay. Now I'm audible now.
Yes, sir. Now you are audible.
Very well. Sorry for that.
Yes, sir. Participant, please put your question in the chat box. We will take the questions.
Okay. Now, therefore, there are many stakeholders. There are many critical issues that are in. Oh, I'm not able to move this. Okay. Okay. There you are.
Now you share the slides, sir.
Mukund,
Yes, sir. From share
I have to
screen.
share the slide, is it?
Yes, sir.
Okay, now I have to go back now to 1 second. Sorry about that.
There is an
something
exit minimize window for the, you can press that.
From Zoom.
Yes, sir. From
Therefore, I was
Zoom.
not able back. I'm unstable now. 1 second. 1 second. 1 second. 1 second. All right, now.
That's okay, sir. You can go on. That's okay, sir. You can continue because I think it's almost the last 1 or 2 slides pending. Hello, sir.
Yeah. So okay. Okay. Now let me see what slide I was in, and then get back to you. All right. So that's right. You're right. So now, therefore, there are anti-drone systems. There are different detection technology. You're not able to see this. Is it right?
No, it's not visible, sir. Yes. Sir, you can make the Zoom.
Not visible and not audible. I'm audible.
Yeah, you are audible, sir.
Share screen, sir. Share screen. There is a share screen down.
In the Zoom interface, sir.
Green button down.
Green.
Next to participants.
No, I'm not able to see the screen. That's why I'm not. No,
so
but
there is
I'm
a
not
red
getting
color leave. There is a red color leave button.
Yes,
Before that, there are some buttons.
I'm not able to see the Zoom.
Oh, okay. There is a minimize exit minimize window.
I'm sorry for that. Shall I leave and rejoin?
No, sir. There is an exit minimize window in screen. If you click that, no, at the end, there is
yeah.
With an arrow. If you click that, it will this thing.
I know, but I'm not able to see the screen. I'm
minimize this window, sir. Minimize this window. Minimize this window and go to your screen.
And then, all right. Zoom is there, but I'm not able to see the Zoom.
Right-hand corner, up right-hand corner, minimize.
I know, but then I'm not able to minimize it.
Right-hand corner.
What?
So minimize the zoom. You can minimize the zoom and you can open your slides and you can speak.
No, but I'm not able to see the Zoom screen at all.
Oh, that's what it's in minimized state. Sir, there at the right down corner, there will be a with a green arrow, exit minimize window. If you just shake, there will be a green arrow, right side, right down corner. Exit minimize. Yes. You can click exit minimize window. You can click that.
Exit minimize window.
Yes, please click that. Please click that.
This one?
Yes, the green arrow. You can please click that. Then you will come to this window.
I'm just not able to do that. No, I didn't, but I didn't see the screen, ma'am.
No, but you told the button rightly.
Shall I take the risk?
No, you can read on, sir. You can read this thing. No problem.
I'll do that. That's what I'll do because there are only a few slides.
Yes.
So there are. But I don't know how to answer questions. Anyway, you'll have to read the questions out.
Yeah. Okay, sir. We will read.
Okay. All right. Anti-drone systems. There are several detection technologies: optical, thermal, acoustic, and magnetic. And in today's context, people also use trained eagles, which is very, very basic rudimentary technology. The beagles which are trained to go and catch drones and bring them safely down. They may get hurt, but it happens. It's possible to happen. But then it is okay if there are 1 or 2 drones, but when they come in swarms, big numbers, these will not happen. There are also drones which are actually linked with net. They're connected to the net, and the nets can be used by drones which are flying close to the rogue drones and make them catch them in the net itself, so that they won't be able to fly. And similarly, we have also drones which, when they spot the drones which are rogue, which are unidentified, they use chemicals, flames, heat waves, high temperature guns, and they can be brought down. But more importantly, it is the anti-drone rifles and spoofing. This is what Bharat Electronics has been doing. There's several. I wish I could show all these things. I'm sorry, but this is not a good thing to happen. But then there are several anti-drone technology systems that are brought, and we have developed at least a few of them in DRDO and Bharat Electronics Limited, which can recognize by suitable technology the radio waves, the radars, and then have a spoofing, jam the systems and bring them safely to a safe place by taking over their control system. And that is possible today. But what is important is to have a complete destruction, neutralize them completely if they're not responding. And that is something which need to do carefully, because the debris that is created, it may fall down into a very difficult location. And therefore that's important. The point I'm making is there are several technologies which are to be developed. We are still in a very nascent situation. And therefore, you guys have a big job opportunity, very big opportunity to get into this technology systems and make a good career out of this. There is a huge potential. There's a need from the government. What I'm saying is indigenous development of anti-drone technologies, like what Bharat Electronics has done. There are several private entrepreneurs, as I said, Skylark Technologies, just to give an example. Therefore, ultimate high potential threat is multi-site swarm drone attack. How to handle swarm if they come in big numbers? How to identify them? How to say it's a friendly, it's a registered, it's an authorized drone or unauthorized drone? It's a very, very difficult challenge. You're seeing a small little set of drones coming at a distance of 3 kilometers at a particular height. They are moving very suspiciously. By tracking their movement, you can probably find out. But you don't know what is their signature or what is the radiation that they're producing. And therefore, we need to study the present DGCA rules, regulations, and guidelines, and compare with the international guidelines. And can you use, the point I made was, can you use the existing IT towers to work as a virtual drone control systems or drone traffic control devices, and network them all in urban and strategic sites? And can you therefore deep dive into understanding the engineering and physics of anti-drone technologies? Unless you do that, it will be very difficult to do that. I'm sure there's a huge potential. So with the passing, I just want to summarize. I wish I had didn't have this issue. Now, the drone applications are proliferating. It's just mushrooming. It is actually an exponential growth in the country, definitely in the world. And there are many, many huge technology challenges. You have huge technology gaps. You saw a few of them. The technology readiness level in the country is low as compared to a global scenario. And the private sector is starting and is moving up. So you have a job potential waiting for you if you look at it. And there's a need for drone traffic management across the country. It's not just one city. You got to protect the entire country. It's cities, it is towns, it's water bodies, it is airports, it's railway stations, marketplaces, all sorts of things. So a huge potential. And therefore, you must create a parallel layer of drone traffic control with the existing ATC. And there is a positive government support and it's been identified as a thrust area. I'm sure there will be a lot of funding and support for this technology to be done in academic institutions, private industries, public sector undertakings, and government-run laboratories. Especially for anti-drone technology, it's a serious threat. You understand. There is a very huge urgency. You know what? You're seeing what's happening in the border. It will happen everywhere. And it's not going to be one drone. It's going to be 10 drones, 100 drones, maybe. Technology level, again, as I said, is a very nascent stage as far as anti-drone technology is concerned. And therefore, there is a need for synergizing industries, R&D labs, and academia. And you guys are the connectors for this. There is the students who are studying or doing these projects, who are doing engineering and associated technologies. You should be able to do, there's a huge job potential. And for both individuals, startups, and MSMEs. So this is all that I wanted to conclude with reference to both the drone technologies and anti-drone technologies. Thank you. Thank you very much. Mukund, I finished.
Yeah, so thank you, sir. Now we will take the questions.
All right, now, okay, all right, very well. I can't illustrate anything while answering this question. It's going to be, I don't know what is wrong with this. Can I still, okay, we're running short of time, right? So we'll go to the question.
So you can try, sir. You can try to open the slides, but these are very basic questions asked by some of the participants, sir. Very basic questions.
All right. Then you shoot it out. I'll try to answer. Yeah.
First of all, your brief introduction and the detailed explanation of drones and the perspective and the future analysis and this thing as discussed by you in detail was very, very, very good. It was very informative. And now over to the questions.
Okay. Thank you. Thank you. Thank you.
Okay.
Thank you,
Sujata, now you could put the questions.
Yes.
Yeah.
There is a first question from a participant, Bhanu Swarup.
Bhanu Swarup, yeah.
Yeah, the question is pilot certification very costly? That was the question asked by Bhanu Swarup.
Right. Bhanu Swarup, it is not very expensive. Don't compare with the costs involved in airline pilots, but that's very, very expensive. And this is basically very affordable. Most of the engineering students can afford. There are 2 or 3 levels of certification of drone pilots. And we need to learn the basics of aeronautics, basics of drones. It's a theoretical subject. You've got to pass a little test or a thing. And then you need to spend a little time on training yourself on flying the drones in an open field under the supervision of an instructor. And there is an examination to pass. I'm not able to give a number. It can be lakhs. It has to be in thousands. So that is easily doable, and it's affordable for students like you, students whoever. And there is several levels of them. One is for engineers, one is for people who are diploma holders and things like that. And so that is, to answer the question short, it is not very expensive. It's nothing to do with the cost involved for airline pilots. Yes.
Thank you. Thank you, sir. There is another question from another participant, Nishat Fatima. And the question is, what is EMI and what is EMC?
Yeah. Well, actually, you must really be asking your instructor, the teacher in the engineering electronics and electrical engineering thing. EMI interface, the system is going to be affected by the radiation to and fro, all right, the electromagnetic radiation that is going to affect the working of the control system, electronic system on board the drone, and therefore you must insulate it. You must protect the system from this EMI, electromagnetic interference. As far as the question, which is EMC and EMI, you please do ask your electrical, electronics, engineering mentors, students, teachers, if you don't mind.
sir. There is another question from another participant, Sivanation. He is asked, why large UAV powered by electric motor? Why large UAV is powered by electric motor?
Yes. Okay. The alternative to that is gas turbines, IC engines. Big drones were powered by IC engines and gas turbines. Now, the control of gas turbines, you need to carry fuel, you need to carry protective system. IC engines are noisy. IC engines are, again, not very efficient in terms of the power thrust to power ratio. And controlling the system is going to be as complicated as can be. Whereas with the electric motor, you are powered by battery. Battery can easily be charged, and the controlling of the motor is very easy because most of them are high power BLDCs. Okay, the brushless DC motors. So the controlling of the electric motor with reference to the speed of the propeller and therefore the controllability of the aircraft is much easier with reference to electric motor. But what is said is not entirely true, because the electric motor are used in drones up to some capacity. But beyond that, electric motors and propellers so attached to them are not very sort of doable in terms of the size of the battery, the discharge rates of the battery. So bigger drones are actually being used, are using IC engines and the gas turbines.
Thank you, sir. Thank you, sir. There is another question. Roshan A, another participant, has asked.
Roshan, yes.
Aerospace, can we use the delta wing in UCAV?
Okay, all right. UCAV is also a sort of drone, if you like. UCAV is unmanned combat air vehicle. It depends on the role of UCAV. Delta wing is basically associated with high Mach number flights, whereas if you want to use the UCAV for a bombing mission, and you need a range, you need to fly at a higher altitude and long range. So there the delta wing may not be a right option. But most of the UCAV, if you see, they have the delta wing. Basically, you are wanting to quickly dash through quickly at a higher speed and complete your mission and come back. And therefore, delta wing is the preferred option for UCAV these days. And if you go for a look at the typical bombers of yesteryears, they were having big LBD, I mean, their span to chord ratio, and they were not delta wings. They were actually simple, typical flat wings with a very high LBD ratio, the wingspan ratio. And therefore, that question is self-answered in the sense most of the UKVs will be having delta wing. That depends on the role of the UCAV.
Thank you, sir. Another participant, Shashwata Ghosh, has asked, yes, how radar technologies can distinguish between anti-drone and enemy fighter planes?
Well, I don't see radars alone cannot do this. There are several complementary technologies information from which will go into finding out whether the incoming aircraft is your own aircraft or, say, for example, an enemy aircraft. As far as the typical aircraft is concerned, in fact, today we have a series of radars, series of control points from where you will get the information that it is emanating from some place outside the border. And this is not, in fact, every aircraft should declare itself, announce itself. What is its identification? What's the flight number? What's the flight permission given? So ATSPs will have an idea of which is an authorized flight, which is not. And if it's not falling within that, the radars will, of course, identify the movement of the vehicle, but it may not be able to tell whether it is, say, for example, an enemy aircraft, a friend or a foe. That is difficult to suggest or explain or identify just by radars alone. You need to have supplementary confirmatory data to do that.
Thank you, sir. Another question from another participant, Sabari Krishna. Here is an interesting question. He has asked,
Yes,
what are the chances for a startup to pitch its anti-drone tech to prestigious organizations like DRDO, HAL, and BEL, etc.?
Yeah, okay, that's very good question, but that's a very practical question too. Now, I just wanted to tell, we had in NDRF, we had a consortium of partners. They were all people who were just like a startup. Some were working as engineers in private industry. Some were working as engineers in, say, public sector undertaking like HAL and so on. And we had the opportunity of connecting with them under this program. They were all started with 3 people, 2 people, and they were all startups. And today, there were 3 of them are recognized by DGCA as possible operators, manufacturers and operators of drones for specific application within the given ceiling. And there are a couple of startups now working in IISc, Institute of Science, and they were all working as individuals, and now they're started up as startups, and they're actually recognized. And some of them, for example, the HALEP I was talking to you, the HALEP, the pseudo satellite, one of the startups has been identified by the Army, it is there in the press report, has been identified by the Army to develop and demonstrate that they can park a pseudo satellite, a HALEP, high altitude satellite, or had a high altitude drone, long range drone for the Army, for their Army operations, and that's a startup. And therefore, you can see a startup, if you're doing good, if your fundamentals, basics are good, you have all the chance. Why only DRDO? It can be directly handled by the ministry itself. And quite a few of my, in fact, one of my students actually from Harvard College is running he started with 3-4 of them. And he is now tied up with all Asian countries, African countries, for operation of his drones, which is being manufactured by him, being tweaked by him, integrated with payloads. And they are doing a lot of applications in Vietnam, in Cambodia, in African countries. So there is absolutely, sky is the limit, really.
Thank you, sir. Very practical question. That was Sabari. Thank you. Now, next, another participant, Vardhan Sendal. He has asked, how do drones contribute to the Army?
Oh, well, actually, there are a lot of things. You can see if you're not having drones, what can really happen. If you have drones, what can happen. But the drones are being, I mean, there are several known application, several, shall we say, undisclosed operations. Basically, you're talking about gathering information. Information is you're prepared with the information, or well equipped to handle a war theater, a battle, maybe a war. But for that information you require, you need to know what is the operations across the border, maybe 20 kilometers away, 30 kilometers away, and you need to maybe have a pilot. You have a survey of this thing done, and this is what the drones do. I mean, they may not do what the satellite can do, but surely across the border, within your operational range. Across the border, what is the movement of enemy in terms of vehicles, in terms of personal movement, and what are the weather conditions, for example, and then, for example, the possibility of mines, the movement of tanks, or movement of armored vehicles. All these things can be surveyed, and that gives you a picture as to what is the possible situation, what is likely to happen in 1 week, in 10 days, and so it's being sort of equipped with the situational awareness. That's one issue, that is gathering information for a strategy. But more importantly, you can also do what others have done. You remember the Azerbaijan-Armenia war in Europe. Azerbaijan, Armenia one of them actually fought the other, not by tanks, not by aircraft, by they won the almost that not war but a battle by using drones which are equipped with armor, with armor, with rockets and small rockets and explosives, and they're programmed to be very precise. Drones can be programmed to be pinpointed. I mean, to go into a pinpointed location without too much of what they call a CEP. The error of pointing to the targeting the location, and therefore we can precisely do without any serious problem. And wars have been won. I mean, battles have been won because you are able to use drones. The drones are very small to be detected by radars. The question that you asked, somebody asked earlier, is very difficult, and therefore you're not going to be countered by their defense systems, and therefore, both for defensive or offensive operations of the army, this will be very useful. But only limitation, of course, is the limitation of the range and the endurance of the drones. Maybe 50 kilometers, 10 kilometers, 100 kilometers, worst case scenario, best case scenario, you can handle both offensive and defensive mechanisms that our army wants. You can make a survey, for example, whether it is you have glaciers, we have flooded areas, so you can assess those situations and prepare yourself. For example, the tanks which are supposed to go, if there's water logging, the huge water flooding, you can find out whether these should be treated as amphibians and get prepared for making the tanks work as amphibians, wade through water. And without preparation, it will be difficult to cross this thing. So if you're knowing what's happening about 30 kilometers away, if it is a flooded area, you can prepare your tanks to do a suitable crossover without serious a problem of getting more down. So a lot of work can be done. I mean, this is just a few examples. I mean, immediately I can think of, but then a lot of things can be done by the army with the drones.
Thank you, sir. And another participant, Zuhair Ahmed, has asked, do we need certification for using drones in industrial work?
Can you repeat the question?
Yes, Zuhair Ahmed has asked, do we need certification for using drones in the industrial work?
Well, actually, drones, I don't know what you mean by drones in industrial work. I am not too sure what you mean by that. But any operation of a drone, whether it is for industrial purpose or for a simple agricultural work, for example, or for any other work, you need to have a certified drone. You need to have a certified pilot, and you need to stick to the present ceilings, which DGCA has given, that is 200 feet to 60 meters, and then it should operate within the visible range. I mean, things have changed. The very recent DGCA rules and regulations have relaxed this requirement, but the three things important: that you need to have a certification, registration of the vehicle, and you need to register yourself as a pilot, and you need to respect the DGCA norms of today. So that is whether it's industrial application or for agriculture or any other application. But I'm not sure what Zuhair has said about industrial application.
Yeah. Thank you, sir. Vardhan Sandal has asked whether drone technology be privatized or controlled by the government in the future.
No. I think that question is no more valid today. It depends on what is meant by control. Production of development, production, and selling, marketing, registration, getting approvals from DGCA is all open to everybody. As it could be a startup, it could be MSME, it could be a big industry. If you look at the profile today, everybody is running a drone program. It is not controlled by the government today. In fact, I can't imagine, recollect a government agency only for drones accepting the Defense DRDO lab, which is developing drones for the services, which are basically for defense application. But for civil applications, there is no restriction as such, and anybody who has got the technology, who has got the background, who has got DGCA clearance, can do. It can be a private, it can be a single individual, it can be a startup, it could be a small scale industry. And so there is no restriction on private operators for drone design, drone development, manufacture, market, and sell, and even operate them, as long as they take permission from DGCA. To that extent, whatever DGCA has given as the rules and regulation, it is a control. But to operate them, there's no sort of clamping. Yeah.
Thank you, sir. And with all these, so many of questions you have answered very politely, and there is one last question from Deepak. What are the internship programs going on for the development of drone? And this will be the last question.
Okay, there are several internship programs. Actually, we started a long time back. I was mentioning, we had a national program in NDRF, and that was sort of integrated with several labs, in National Aerospace Lab, IISc, IITs, Anna University, and they're all partners in this. And each one of them took interns for these programs, national program on micro air vehicles, but that was a small program, small in the sense it was not comprising of all types of drones. But today, everybody, as you mentioned, startups, in fact, the 3 or 4 startups I was talking about, they have started on their own. And as a startup, they have already taken 3 or 4 interns for internship from the engineering colleges to work with them, to support them in the process. They also learn they learn their technology, and they do their project as interns, and that both is a win-win situation. So there is a lot of scope, not necessarily only in places like what I was mentioning, but in, for example, in they take a lot of students for the drone technology as a project students, interns, if you like, and this happens everywhere. In IITs and ISC, in labs like ADE and NAL, for example. So it is happening all over. So there's a tremendous potential for internship. I mean, what program, if you ask me, I don't know, because then it depends on what exactly. It could be electronics, it could be control system, it could be manufacturing, it could be flying. In fact, every lab which flies the drones need 3 or 4 licensed, experienced pilots, and then today they can't fly without getting an approval from DGCA. So there is a large-scale requirement for interns for in this particular area, and in places where this is happening.
Sir, one more question from my side, sir.
Yes.
PG courses or diploma courses on UAV after BE.
Yes. Yes.
So the question is like that, sir.
Okay. Now the question is, are there any postgraduate diploma courses in drone technology? I don't see it. I've been with these border studies in several universities. All the universities are actually geared up for supporting their own students, both undergraduate and PG students, plus PhD programs. They're all for the internal students. And there are courses, especially for UAVs, both in undergraduate level as a core course, as well as elective courses. And there are also what we call optional subjects for other departments. But there is no, yet I'm not aware. Maybe there are some universities elsewhere in North Indian universities. They may be trying to do under skill development program. It's not a part of the curriculum of the undergraduate and postgraduate courses, but this is possible that these drone technology, I don't know, again, the drone technology is a huge thing. So drone manufacture, drone design, drone operation, And so such skill development programs might be there, where, for example, the Ministry of Industry, for example, they're trying to support a lot of MSME programs, right? So they may be supporting these institutions to deliver, to give courses as a part of the skill development, but I'm not too sure. In the existing university structure, postgraduate diploma, postgraduate certificate for drone technologists is, I've seen. It's all part of the ongoing graduate and undergraduate, postgraduate and undergraduate programs. Mukund.
Thank you, sir. Thank you for the wonderful session on drone. I hope the participants must have got valuable information on this session. Now we have come to the final end of the session. But before concluding, I would like to remind the participants for tomorrow program. We'll meet at the same time, 5 p.m. tomorrow evening. And also, tomorrow there will be 3 parallel sessions for mechanical, civil, production. And the topic will be lasers in manufacturing. And the speaker will be Dr. M. Durai Selvam, Professor, National Institute of Technology, Trichy. Once again, I thank Sir to share the valuable information on the second day of the 14-day online internship program. Thanks one and all. Thank you all the participants for your participation, support, and encouraging queries that were shared. It was really a wonderful session. Thanks one and all. Over to Mukund.
Okay, thank you, participant, and thank you, sir, for your valuable information for the student.
Yeah. I'm able to see you, Mukund. So therefore, the Zoom must be active. I lost contact somewhere. I don't know how to, I didn't know how to share that for last few slides, but I'm sort of disappointed that I couldn't complete it in total. But then thanks anyway. Thank you for this good session,
Okay.
very well arranged. So we'll catch up. Thank you and your other colleague who compared it so wonderfully. Thank both of you. And of course, I must thank, I didn't say this, I thought I'll do it later. I must thank Dr. Anadrai, the chairman of NDRF, and Dr. Dilip Babu, for director of NDRF, for giving me this opportunity and including me in this list of topics for internship. And of course, you, Shankar, and ma'am, I must thank you for helping me out on this today. And I'm sorry again, I must, on a Sunday, I have no business to take more than 1 hour of the students' time. I did maybe extend by half an hour.
Sir, it is actually the other way. We took your time, sir. We all took your time. It was that way. The NDRF internship program is presented in association with IEI Kanpur Local Center. And all the participants must have really boosted their knowledge on this session. We had a wonderful time, and the 2 slides which you told that was missing, we didn't miss anything because there were a lot that you shared.
Oh,
it was really a wonderful session.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you. Good day. Have a nice weekend, Sunday evening. Thank you.
Thank you, sir. And all the
Thank you, sir.
participants, kindly participate tomorrow at the same time, 5 p.m. Thanks, one and all.
I'll sign off. Thank you.
Now we are ending the session. Okay, now we are ending the session. Thank you.
You can close that, Mukund, from your side.
Yes.
I don't have a button to leave. Thank you.